Okay, so to start out chapter 5, we're going to be starting out by talking about inequalities. Some of this is review from what we did, from what you've done in the past, but we want to make sure that everybody's on the same page and understands some of the basics, so that way we can apply it to some of the more challenging stuff that we'll be talking about in this section and in future sections. So to begin with, let's just talk about these different phrases. So we have these two less than or equal to, or we have greater than or equal to. The symbols for these are, anytime it's just less than or just greater than, it's just going to be just the inequality symbol with no line underneath it. So less than is just going to be the less than symbol. Less than or equal to, that means that it's less than or equal to that value. And that means that the number that we're looking at, if I have an example like x is less than or equal to 3, that means that 3 is included as part of my solution, and everything less than that is also part of my solution. Or if I said x was less than 3, 3 would not be part of my solution, but everything less than that would be. Greater than and greater than or equal to mean the same thing. It's just that it's dealing with greater than. So if I had x was greater than 4, that means that I'm including all the values for x that are bigger than 4. However, if I said x is greater than or equal to 4, that includes 4 as part of my solution. Which brings us to graphing things on a number line. We're going to be graphing our solutions. We're going to solve an inequality here in a minute. And when we get finished with solving it, we're going to graph our answer on a number line. So there's certain ways that we identify whether it's less than or equal to, or greater than or equal to. If it's less than, like we said, it doesn't include that particular point. So we use an open circle when we graph it on a number line, and we would draw an arrow pointing to the left because it includes all the points less than that value. If it's less than or equal to, we use what we call a closed circle, so we make sure that it's closed, that it's filled in. And it's less than or equal to, so that means it includes that point and everything less than that, so we go to the left. It's just the opposite for the greater than or equal to. If it's just greater than, it's an open circle because it does not include that value, but includes all the values above it, so we're greater than that, so it'd be to the right. Greater than or equal to includes that value, so we use a closed circle, and it's all the values to the right of that, so we go to the, or greater than that, so we go to the right. So let's look at something more tangible with this inequality. Now here's the deal with solving inequalities. The process is the exact same as solving an equation. Here's the only difference. When we solve an inequality, if we ever multiply or divide by a negative number, we need to do something really important. We're going to flip the inequality. But the key here is it's got to be a negative number, and we got to be multiplying or dividing. So if we ever multiply or divide by a negative number, if we multiply or divide by a positive number, it's fine. It doesn't change anything. But if we ever multiply or divide by a negative number, then we have to flip the inequality. So let's look at some examples. Let's look at this first one. 2x plus 8 is less than 12. So if I go to solve this, like I said, we solve it just like an equation. I'm going to start by subtracting 8 from both sides. Doing so, I'm left with 2x is less than 12 minus 8 is 4. My last step to solve for x is I want to divide both sides by 2 to get the x by itself. Doing so gives me x is less than 2. I didn't have to flip the inequality because I divided, but it was not by a negative number, so this will be my answer. And like I said earlier, we're going to graph our solutions on a number line. So to graph this on a number line, I would start out by using an open circle at 2 because it's less than 2. It doesn't include 2, but it's everything less than that. So we draw an arrow going to the left. Let's look at another example. Here we have 8 minus 4x is greater than 20. Again, we solve this just like we would any other equation. I want to get the x by itself. My first step in doing that is to get rid of this 8, so I'm going to subtract 8 from both sides. Well, 8 minus 8 is 0, but I'm left with a negative 4x is greater than 20 minus 8, which is 12. Now I divide both sides by negative 4. Notice what I just said. We're dividing by a negative 4, so we have to flip the inequality. So instead of x is greater than, it's going to become now x is less than. And now I take 12 divided by negative 4, which is negative 3. So x is less than negative 3. So now to graph this, it's going to be an open circle at -3 going to the left. So that's how you graph inequalities. We can always check our work by picking a number. So I'm saying that if x is less than -3, if I pick a number less than -3, like -4, it should make a true statement in my original inequality. So let's put -4 in here. -4 times -4 is a positive 16. 8 plus 16 is 24, which is greater than 20. So that is a true statement. Let's try another one. Let's say if I forgot to switch the inequality. Let's say if I said x is greater than -3 and I picked 0, because 0 is bigger than -3. If I put 0 in here, -4 times 0 is 0. 8 plus 0 is 8, but 8 is not greater than 20. So that's an easy way to check to see if you did it right. So then if you had x is greater than -3, you could try to find your mistake and remember to flip the inequality. Let's talk about compound inequalities now. A compound inequality just means that you're combining more than one inequality. So if I have x's, and when we combine inequalities, when we have compound inequalities, there's two ways that we can combine them. One is by using the word or, and the other one is using the word and. Using the word or means that it's going to be either in one category or the other, but it's not going to be in both. So I could have a number that's less than -1 or greater than or equal to 0, but there is no number less than -1 that's also greater than or equal to 0. But let's visually show this on a number line. So if I graph this, x is less than -1, that means it's an open circle at -1 and going to the left. Here you have x is greater than or equal to 0. So we have a closed circle at 0. And it's going to be going to the right. And that would be your solution set. That's all you'd have to do for this one. But notice how there's nothing that they have in common. Now, when we use the word and, that means we're looking for a solution that's true for both statements. Where we look for a set of numbers that are greater than or equal to -1 and less than or equal to 3. Like, for example, 0 is greater than or equal to 1 and it's less than or equal to 3. So it will be in the solution set. We want to see what all the numbers are in the solution set. So we're going to use that, or do that by graphing. Okay, so I start out with a closed circle at -1. And it's going to go to the right, but I'm not going to put an arrow. You'll see why in a second. And then it's going to go up to where x is less than or equal to 3. So I'm going to use a closed circle at 3, and it's going to be less than or equal to that. So this would be my solution set. Anything from -1 to 3 would make a true statement. Because if I put -1, -1 is greater than or equal to -1, and -1 is less than or equal to 3. Or 3. 3 is greater than or equal to -1, and 3 is less than or equal to 3. But if I pick anything outside of these, it would make a false statement. So this would be my solution set, going from -1 to 3. Now let's look at this one. This one's also slightly different. Notice how we have our smallest number is -2. Oops. Our largest number is a +3. Let me change this up a little bit. Okay, so what that means is that I'm going to use an open circle here at -2. Now if I look at this backwards, I know it says -2 is less than x, but that used to always confuse me looking at it that way, so I like to read things and put the x in perspective first. So I'm going to read this as being x is greater than -2. So that means my solutions are going to be greater than -2, but less than or equal to 3. So I'm going to have a closed circle at 3 and a line going between these. So -2 is not included, 3 is included, but all the points in between those are also included. So that would be your solution set. So anytime you see it written like this is the same as when we see the word and. So we're looking at what numbers they have in common. An easy way to remember it is if you notice x, when it's written like this, is between the -2 and the 3, meaning that's where your solutions are going to be at. The only way to represent a situation with the word or, where it goes in two opposite directions, is going to be like this, using the word or. So hopefully you have an understanding, and hopefully this has refreshed your memory on how to use inequalities, so you'll have success in your assignment. Good luck.